We are very excited that we have a sponsor for this webinar. It's really appreciated any contributions, especially to cover the cost for the CPD validation. So we're really appreciative of Raw Modular that they wanting to sponsor this webinar. So Raw Modular is a product and furniture design company that believes that environmentally responsible engineered timber materials, digital manufacturing, and modular thinking is the way forward. At Raw Modular, they design, develop, prototype, and make sustainable modular design solutions, furniture systems, and compact living structures that simplify the way you work and live. They have been honing their modular design skills and services for over 18 years with many successful projects and products to show for it. Their latest passion is to engage in the training of design students and professionals with a week-long, fast-becoming epic design and maker camps. The experience and knowledge behind them, Raw Modular will be hosting a 2-day CPD accredited course that aims to familiarize participants with the fourth industrial revolution process of digitalization and manufacturing in engineered timber by enabling them to go from a modular system generation through CAD design and CAM operations to a physical prototype that can be tested and further developed. So for those who are interested in such a 2-day experience, please go to the website, and Lisette will put a link in the chat box as well to sign up for this event, which will be happening on the 23rd and 24th of June this year. And I'm going to show a video now that will give you an idea of what is going to happen in those 2 days.
Welcome to Raw Modular. 15 students from the University of Pretoria were given the opportunity to eat, sleep, and breathe the Raw Modular experience during a plywood design and construction week. The brief was simple: to design a structure or structural system out of modular plywood parts that spans at least 4 meters over an uneven surface and that can handle the typical directional forces such as tension, compression, torsion, and shear force. Ultimately, they had one goal in mind: to produce a full-scale prototype that can withstand half a ton of pressure. The 15 students were divided up into 2 teams, eventually named Team Armadillo and Team Greyhound. Each team started by developing their ideas into concepts, which, guided by experts in the field, they were able to translate from conceptual designs into workable solutions using the latest CAD and CAM software. Laser cutting and assembly of their initial design solutions into 1:5 scale cardboard models helped the students not only to analyze, but also visualize their designs before moving on to the full-size prototype. After a meticulous nesting and toolpathing process, an excited atmosphere surrounded the CNC machine as each piece was precisely cut. As a team, they had to work together to assemble and join the components. When the structures were assembled and many selfies were taken with the results, the only thing that was left was to test the prototypes by subjecting them to heavy sandbags. As you can see, Team Armadillo's structure handled 12 sandbags with ease, which is the equivalent of 500 kilograms. Team Greyhound's structure did not make it to 12 bags. Due to a small flaw in their design, they were left picking up the pieces. Team Greyhound's error in judgment did make for valuable lessons being learned in the various ways of joining and fixing plywood. Let's take a moment to hear from the students about their experiences.
Well, what I've enjoyed most about being at Raw Modular is, I would say, the sense of community in how the staff look after each other and how we work together in these tight-knit small groups.
The most interesting thing we learned this week is the unexpected ways in which timber can be used and applied in different ways.
Piet and Clara have been amazing. So this whole environment has been quite conducive for us to learn more, in terms of digital workshopping and construction.
I think one of the coolest things I've done was the camping experience. Yes, it was a bit cold in the beginning, but then I guess we have adjusted so far.
Getting to know one another, getting to learn from one another, and also seeing the progress from students, how they learn all the skills in a very short period of time. And the output's been amazing.
How a theoretical idea translates into a physical item and working with your hands to accomplish that.
We're here with 15 students this week. These are architectural students who are eager to learn about digital fabrication and timber construction. So the University of Pretoria, in association with York Timbers, have set up this program to further the timber construction industry, exposing young architects to ways of fabrication, ways of design, structural, plywood, strategies, etc., to get them up to speed with the fourth industrial revolution, as they're calling it.
To the group of students, we've learned so much from each other. We were seriously impressed by the way you approached the problem from different angles to create two very different, yet innovative outcomes. And we are extremely excited for what the future will bring. From all of us here at RAW, we thank you for this experience.
Okay, so I'm sure that got everyone excited. So again, if you want to sign up, just go to the website of PIA and and enjoy. Okay, so for today, we're talking about timber, but just very briefly about the Regenerative Collaborative of South Africa. We're a voluntary organization, and at the moment, we're mostly doing these monthly webinars. We would really appreciate it if you can follow us on LinkedIn or Eventbrite. If you like us on Eventbrite or follow us on Eventbrite, you also get notifications for the next webinars. Yeah, and if you want to join, if you want to volunteer your time, always welcome, of course. Just be in touch with us. And then we're also looking for 3 interns at the moment, someone that can help us with the video editing, with social media, and possibly a web developer. So there's currently these 3 job descriptions out there. So if you know anybody that would be interested, email Adele Hoskin or me, myself, and then we'll share the job descriptions. All right, but let's now go to the topic, timber construction. I think a lot has happened. We did 2 webinars last year, in 2021 in November, and then in January 2022. And I thought it was a really good time to revisit the work that has been done over the last year. And I know a lot has happened. And there was the timber conference, I think it was a month ago. So we looked at their program and decided to invite Marcus and Christian to this platform and share their presentations here. So I'm going to introduce the speakers and then I'm going to let them take over the floor. So first up is Marcus van der Hoven, co-founder and managing director at Mass Timber Technologies. He's a furniture designer and manufacturer, and he holds a master's in architecture from University of Pretoria. Mass Timber Technologies is a timber prefabrication company specializing in the manufacture and supply of large-scale complex building components for use in construction applications. And they have a facility in Johannesburg. And he's going to be talking today about mass timber construction in the South African context. So we're looking forward to that. And then the second speaker is Christian Greyling. He's born and raised in Pretoria. He's born in Pretoria and raised in the Highveld of Mpumalanga. He's grown up in a family of artisans, learning from his father and grandfather. He developed a keen sense and ambition for making. He returned to the mother city to pursue architecture, and his pragmatic thinking and ambition for making have developed his design methodology into a unique blend of approaching architecture. And I know he did his master's in timber construction as well. And he even designed his own container tiny house, which I'm also very interested in. I'm not sure if he's going to talk about that today. But his title of the presentation is Scalable Timber Systems, a Modular Approach from Furniture to Structure. And I'm going to hand over to Marcus.
So thanks for that introduction. Yeah, I'm Marcus van der Hoven, and as Marlies let you know, I'm the Managing Director of Mass Timber Technologies. We're a mass timber prefabrication company, focusing really in the design section and then all the way through to the fabrication of cross-laminated and glue-laminated timber components on a scale that South Africa really hasn't seen yet to date. We've been working on this concept for around 3 years now. I think it is about 3 years, and recently closed quite a significant funding round to provide us the necessary backbone to run everything from a feasibility study section all the way to a proof of concept section. And now we're moving quite rapidly into quite a large scale-up process of our manufacturing system. And today I'd like to run through a few concepts based around our learnings in developing the mass timber system and developing mass timber components really for a more South African or African context, providing something that's a bit more relevant to our context and our environment and our budgets really to what we've seen, really practiced internationally. Some of the concepts that you'll see us work through inside of this entire presentation, although I won't, lean on either of or any of these concepts quite intentionally, but you'll see the themes carry through. It's just some important points as manifesto to what we do at Mass Timber and the message that we're trying to drive through to the construction industry as it also develops. And it's important for us to bring some of these concepts forward as we become more aware of the impact that construction has on the environment, the impact that it has on our economy, and the impact that it has on our future. And it's important that we don't really sit back and wait for the disaster to unfold, but stay proactive in developing and continuing the progression of just material knowledge, fabrication ability, and design capability. So today I'm going to touch on 4 key aspects that we think is really important for the larger industry to start becoming familiar with as we design mass timber structures. We've managed to figure out the process of creating the material from a locally available source. And now it's up to the construction industry to skill itself up to accept this material into its process. Testing of the material all the way through structural, fire, economic, and in terms of longevity, we've been able to prove these concepts throughout the mass timber life cycle. And we're finding that a lot of the key aspects that need to be worked on at this point is really the understanding and the capability of architects, engineers, quantity surveyors, and consultants in general to really engage with the projects of the product and allow it to integrate itself a little bit better into the environment. Just to touch on a few elements again, to kind of drive the message home for what we're talking about and why this is relevant in the larger construction industry and the larger drive towards a more positive, sustainable environment. We all know what the impact is of construction in the environment, and key to this is the impact of the manufacturing of a lot of these materials. When it gets to site, that's one thing, but the production process of elements like steel, aluminium, and concrete bear the brunt of the force of CO2 emissions and the global warming impact on the environment. And this is where we see the low-hanging fruit really for a new structural material that can replace a lot of different elements inside of a building and have a massive impact on our environment and the health of people around us. And that's really what we're tackling. Importantly, again, these movements are happening all over the world, and South Africa seems to be dragging its feet. As a total population, our global GDP, our local GDP ranks only 32 in the world. So we're not really punching to the weight where we're actually emitting. So we're listed as the 12th highest emitter of CO2 into the atmosphere globally, but we don't seem to be pulling our weight in terms of economic contribution. So we have quite a lot of catching up to do. And when you contextualize the requirements for building in general over the next couple of years, you can see that the population requirement and the development requirement in our country is far exceeding that of the rest of the world. So it's our opinion as quite a young team that there's going to be a serious boom in construction and construction requirement in Africa over the next coming years. And we need to have the technology in place to be primed and ready for this boom. There's a lot of different elements in policy that are also starting to affect us. We've seen that the C40 policy that's come through over the last couple of years is aiming to have all buildings in South Africa net zero, new builds net zero by 2030, and all buildings by 2050. And what's interesting is that it's not only the architects that are understanding this and fighting for this, but developers are starting to open their eyes to this. This is probably going to be one of the largest liabilities on a development portfolio inside of the next 10 to 15 years. So there's huge progression in terms of thinking and questions that are being asked in new project developments that we're exposed to. And it's up to us to really develop the technology to feed this hungry monster of construction. We're seeing this large movement from a carbon-based material system to a more organic, bio-based, fiber-based system. And it's a process that's happened over millennia in terms of a carbon pool being generated through trees decaying and turning into coal, and then us mining that over a couple of 100 years, and we're trying to basically turn this thing on its head and replenish our carbon pool back into the earth and sequester it so that our atmosphere remains breathable and our temperatures remain cool. So let's talk about CLT as the solution. I'm not sure how many of you are familiar with cross-laminated timber, but it's a fairly simple concept. We're using the structural capability of solid timber, and we're basically adhering it together in a cross-laminated perpendicular lamination, which essentially allows for a understandable and what's the word I'm looking for? An understandable engineering curve, so it's predictable. It's a predictable engineering value that we can then design with in a rational way. Organic materials tend to have different strength characteristics throughout their actual form, and we're trying to turn that organic material into a uniform number that we can then design with rationally and predictably. And we're seeing this happen on a scale that we haven't seen before. All over the world, specifically in Europe and in the US, we're seeing buildings go up at an incredible rate and at an incredible scale. This here is the Milwaukee Ascent Tower, which is now the tallest building, soon to be surpassed by quite a few that are being constructed at the moment, but this one is finally complete. And you'll notice that the building is pretty much half and half, concrete and timber. And that's just one of the elements that I want to discuss today, which is hybrid timber construction, where we make use right now in 2023 of the best characteristics of each material, where concrete may still be required to perform a certain requirement, but we can actually replace a majority of the concrete use that we would typically use to construct the remainder of the building, or use timber specifically in primary structural elements to lighten the load of that structure, lighten its foundation loads, and sequester carbon while we're doing it. So a building like this, I'm not sure if this one was quite net zero, but it came really close. And that's really what we're trying to do, is get engineers who are capable of doing this, provide a product that can hold the loads that are required, and then test it to the point where we can still have the building insured and constructed in an economical way. And this is the fastest route that we've seen to getting mass timber going. We've seen some of these products or projects really become real in our local context, although it's been in the commercial sense quite it's really just the skin of the building. It hasn't really been critical structural parts, but it's still been a significant mass. This is a project done by XLAM in Cape Town, And yeah, it was an absolutely beautiful project that was completed quite well. And this had a very, very it was a substantially different carbon profile or sustainability profile to the buildings around it, which is why we celebrate it as a good example of mass timber in the country. This is our facility in play right now. We're busy constructing a 4-story high building, which is on its way to Zanzibar and is to be constructed inside of the next 3 months. We'll talk about that project a little bit later, but just to illustrate that we are now producing on an industrial scale panels that are between 66 and 200 mils thick, and right now about 6 by 1.9 meters in panel size. So these are some pretty significant pieces of timber, really, in the end of the day, that are absolutely outperforming what we've thought they could actually do. So yeah, the material's doing what it needs to do. We've been spending quite a lot of time with the University of Pretoria and University of Stellenbosch to run through testing protocols. We've managed to get our SATA certification. And that's a really important thing to note, is that CLT is a nationally recognized building system. There's a SANS code for it. It's the SANS 8892 for performance-rated cross-laminated timber. It's available, and our buildings are now insurable. So there's no more excuses for us to no longer be designing with timber because it's not a code. There's substantial information there to actually make this material work, and yeah, there's nothing to wait for anymore. We've got our stamp, and it's a certified material to run with. So some of the things that we need to just run through in terms of designing. I mean, it's all good and well that we want to design with CLT, but how do we do it? The big questions are really around the cost. I mean, it is more expensive than pouring concrete. That's true. We're getting pretty much to the same price as steel now, with the price of steel going through the roof. But we need to really look at how we make the process more efficient to make the product more efficient in terms of its costing. The whole costing profile needs to be redesigned, but there are really interesting ways that we can actually make this process work from the design side, rather than necessarily trying to replace concrete one for one on a project. So the first benefit that we have with CLT is prefabrication and robotics. So our system at MTT runs around the CNC manufacturing process. We have a robot like this on its way from Spain. It's pretty much identical to what you're seeing here, where we've got a really massive saw blade attached to the end of an industrial robot arm, and we've designed software that will essentially allow us to run from any design software like Revit or AutoCAD or whatever it is that your profession works in. And through some integrations through Rhino and Grasshopper, we've managed to design a parametric software integration with the robotic system that we use to CNC cut out material. Alus mentioned that I used to be in furniture manufacturing. A lot of furniture is manufactured in the same system, and that's how we're starting to look at buildings now as well. As we're breaking down into basically designing buildings with very large sheets of plywood, and that's the concept that we're trying to get through. So what we're trying to really push for is the efficiencies through digitization. And what you'll see is that if you just rack us up in terms of our digitization index, or where construction lies as a profession, you'll see that we sit right in the bottom left corner, which is not a good place to be. What we're trying to do is elevate ourselves out of that position by leveraging two concepts, and it's really advanced manufacturing, where we're talking about, Formula One car design and manufacture, very, very accurate technology used to provide a low waste and high accuracy product, and then also information and communication technology. So how we as professionals communicate with one another to make the process more efficient, to limit waste on site, limit changes on site, and allow us to get to a building much faster and help people execute the economics of their building more quickly. So getting people renting their structures faster, less time in your lending profile where your building is actually not being productive. And that's what we're trying to do. This is rapid build with a low waste profile. The two products that we focus on at this stage is cross-laminated and glue-laminated timber. There's a lot of timber products out there that we could explore, but these two were the low-hanging fruit for us in terms of understandability, and our ability to actually engage with the value stream and the value chain and get it to market as fast as possible so that we can start innovating in the timber space quickly. So cross-laminated timber is really a very large block that could work as a floor slab, a roof slab, a wall, but really a primary structural element that can carry load. And GLT is columns and beams. With those two elements, we can start attacking quite a lot of different elements of the structure. And this is where we wanted to start with the process and start innovating. The next thing that we started looking at was exactly that integration of Revit and building information modeling systems, take that into a manufacturing system. And this is, again, something that we're not seeing in the construction industry at this point. Usually we're looking at plans. As plans get submitted to a builder, the builder tries to figure out the formwork on site. It takes months to figure it out. There's often mistakes and rebuilds in place, and that's waste and that's time, and those are things that we don't actually want to do on our construction sites. We want to be quick, clean, and efficient and healthy, and those are the elements that we're trying to push forward. So once we start understanding the benefits of CLT, of course there are downsides to CLT. You know, there's a lot of elements. It's not a silver bullet that's going to solve all of our problems, but we need to understand what it is that we're looking to make more efficient inside of a building. And I won't go through all of these. We don't have enough time. All of this is available on our design guide, which is free to everybody off of our website. You can go and download it and you can run through it. And it's quite a nice document to actually just familiarize yourself with all of those elements. We've even done all of the hard work for you guys. We've worked out all the engineering. We've tested the material. We've worked out based off of multiple different samples from different materials all over the country to get a rational design point where we can say, this is what SA pine at this grade and this is what eucalyptus at this grade are going to do. And you can actually start designing your structures now. Of course, we'll be able to assist you with engineering and your product design and your connections and how it all comes together. But ultimately, the work's been done. So you can actually engage with this design guide and go and apply all of these elements to your own design thinking and start developing your buildings with mass timber in them. The thought concept here really for us is to move this whole process where when we start just designing and engaging with a project program, we see that we've got to do a lot of different work. I mean, as an architect, I kind of get to engage with a lot of these different elements. An engineer has to engage with a lot of the different elements. The green consultants have to engage with 3 or 4 of these elements, and it creates this very sort of intersecting mesh of concepts that need to be rationalized between multiple professions. And this is what we need to do on the cloud space with the building inside of a 3-dimensional space that can be shared and worked on collaboratively. And where changes are tracked and understood, we can actually work on these elements way more efficiently than trying to do it on site. And what we're trying to do is basically create a system whereby after all of this cross thinking and interweaving of professions, we just really want to put out a very simple process for the construction system, because that's where we see the waste and that's where we see the efficiencies really lacking. We don't want to see this mesh on the other side of the material design system. So once it gets into construction and assembly, it needs to really be a program and an assembly diagram. So we're starting to think of buildings and building components as QR codes or barcodes. We can then just track parts, know exactly where they go, and think of it like a Lego instruction kit where you've got 3 parts, an assembly order, and anybody should really put this together without an issue. Once we've actually got through all of this, once we've gone through all of this work together, so yeah, once we've actually completed the design and information modeling system, we can then go and cut these elements out on our CNC program to a very high accuracy, which again helps people just put things together on site in a way more effective manner. Once we've actually put these components together, it's important to just understand the scale and opportunity costs. And this is again where we start to rationalize the elements of CLT production in a contextual way in South Africa. So one of the projects that we've been working on is this house tailor system that we've worked on with a local contractor, a designer out of Durban. He's done a project where they've removed a section of the roof and they've actually just placed a new first-story addition on top of the existing building. And a lot of the work they wanted to do was to actually ensure that the bottom of the structure was unharmed. You know, they have a very expensive floor system on the bottom, and they didn't want to pour concrete slabs, and they needed to do this in a very rapid way. So we designed this system. It was an entirely prefabricated system. We never actually met the architect in person, but we rationalized the whole system over a BIM conversation. And we created the kit of parts for the contractor to work with, and did all of the different component drawings. And we constructed this model as a mock-up inside of our factory. It was important for us to test this, as it was quite a complex geometry that we needed to put together. And we managed to have a contractor come in with the help of our gantry crane, but without any of our assistance. A person who's never worked with CLT before was actually able to assemble this entire structure inside of one day, which is quite an achievement in our mind, considering how complex the geometry is. So this building is actually going to site next week, and there was quite a few delays with the weather over the last couple of months, but we're excited to see this happen in the real world on top of the structure. And there it is when it's completed form. Some other elements that we've been working on as things to kind of carry home with your thinking is concepts of remote working, where you've got structures that need to be placed inside of contexts that have no water or electricity, and you need to actually perform, you know, high performance slabs, high spans to create large open formats, but also remain quite cost effective. So these units provided by Boxer, it's one of our partner companies, can essentially be assembled anywhere in the country within about 5 days of getting to site. And these have been very successful in terms of how rapidly they've been able to come up and solve a problem quite quickly. So again, all of this comes down to being able to model this product quite well and place all of these components into context before you go to site, so that you can do it in 5 days. And it's an important concept for us to continue developing, running through all of the plans for manufacture, checking everything, and then being able to run it through. Once we start engaging with this on a slightly larger scale, that's where things get more exciting. So here's the project that we're doing in Zanzibar. This red line kind of indicates the first set of blocks that we've been tasked to create. We're doing 22 structures in total, and the first one's just been completed now. It's a 4-story high equitable housing scheme. It's called Sheshe. The buildings aren't amazingly beautiful, but I mean, it's not really about that. The fact of the matter is that they are about 98% timber. The only element inside of this building that isn't timber are the concrete cores, which were kept concrete for fire regulations in Zanzibar. And the rest of the structure is glue-laminated beams and columns, and then the walls and the floor slabs. So again, the whole process was worked through a project team inside of a BIM space. We had an architect out of the Netherlands, an engineer team in Germany, and then we had the contractor in Zanzibar and Germany. He was running between the two. We developed this entire building all the way from nothing to completely fabricated without any of the project team being in the same room. And that's I mean, just testament to the power of building information modeling. You know, it's quite a unique project in the sense that we understood what the challenges are going to be for mass timber on this scale, where we've got concepts of 145 unique timber parts and 1,091 total timber parts that need to be designed, drawn, documented, fabricated, and then shipped in the correct order to ensure that the production system is put in place. But again, because we're smart millennials, we've managed to design all of our integration to happen inside of a computing space. So none of this work was really tediously drawn by a poor technologist sitting behind a computer and being fed Red Bull all day. This was a process of about a week. It was done by one person, and it was sent out inside of that week for approval. So this is where we see the power again of understanding your Rhino and Grasshopper integrations, being able to parametricize not only your design but also your documentation process. So this has helped us really just elevate with a very small team and become quite effective in terms of being able to deliver these large structures. And there it is. I mean, there's about 230 cubes of timber, weighs about 115 tons of timber. We produced it in about 3 months. Which was a bit slow for us. We thought it would be a bit faster, but it was a bit of a supply chain issue over December with all the rain. It's leaving in containers next week, and we estimate that the structure will probably be built inside of a month, which they tested on site with another building that was exported out of Germany. So our cost profile in Africa is just a lot better. This is why they're engaging with us, and we're excited to see our first multi-level structure go up this year still. So again, back to the design guide. We've, through this process of designing that building with the Germans and the Dutch, we've managed to leverage a bit of their design thinking to help us develop a set of details that are a bit more contextually relevant to South Africa. So we're not designing walls that are 500 millimeters thick with 3 insulation barriers and moisture barriers on inside and outside and windows that need to do crazy things. We've managed to basically create the performance rating of a 2-brick wall, really. And that could be as thin as a 66 mil CLT wall, can do the same sort of performance if you treat it right. And we aim to educate and assist people in understanding how to detail this properly, because CLT can't be left outside. It's not like a Wendy house. You have to wrap the building and protect the timber, and that's how you make it last for 100 years plus. So that thinking is where we have to change our mind in terms of timber building in South Africa. It's a solid mass material. It's not a 114 by 38 with some battens on it. It's a proper mass that needs to be protected from the elements. Again, we just have to wrap our head around the core of the conversation really here is not really for me to convince you to use mass timber. That's up to you. The drive that I'm trying to push forward is that we're not messing around anymore with this technology. We're developing structures that are now reaching about 11 stories high, and we've managed to develop systems that can actually perform in a way that we can meet the regulation requirements for these heights. We can meet the cost benefits or the cost requirements for these projects, and we can hybridize our system to make it work in a way that allows us to actually participate in the building environment. And where we're starting to see this really work, and I'll leave you with this one thought really, is floor slabs, for example. It's something that we've innovated over the last few months. And when we start racking it up against what we're used to in terms of reinforced concrete, we're looking at reducing a building's weight by 70%. And I mean, if that doesn't say what it needs to say, then I don't know what more to do. We're sequestering carbon and we're able to reduce construction time and deliver something that's way more healthy than what's out there right now. And it's happening on a commercial level. So apologies for the long speech, but yeah, I'll leave it there for now. Okay, thank you.
Thanks, Marcus. That was definitely very interesting. Yeah, the design guide is on the website. I put the link in the chat so you guys can have a look at that. From all the hands and thumbs up, I think people really enjoyed it. Let's go to Christian.
Good afternoon.
Yes, go for it, Christian.
Okay. Yeah, thank you for having me, and good afternoon, everyone. I'm Christian Greyling. I'm a candidate architect here at Earthworld Architects, and today I would like to talk to you a little bit about how we, as a practice, approach timber construction in the South African building industry. So in the beginning of this year, I was fortunate enough to be invited to give a talk similar like this at the Wood Conference in Cape Town. It's a largest conference in South Africa that's all about wood. It comprises of a lot of speakers from around the world, architects, engineers, and developers. And one of the buildings that was presented at the conference was this one you can see on the screen. It's the Swatch HQ located in Biel, Switzerland. As you can see, it's a massive free-form timber structure. The nature of the structure provides for interesting and aesthetically pleasing aesthetics, as well as some warm interiors. But in the South African context, it is a little bit different than in the European or North American countries, and we have different challenges than they do. So I want to kind of just delve into our mindset and how we kind of approach these challenges in our construction industry, and how we actually use the challenges as a catalyst for providing or developing solutions to actually also produce timber construction buildings. So today I would like to talk to you about our design philosophy, and then from there I will just show you a few projects. I've scaled them all the way from furniture to complete building systems. So let's get started. So scalable timber systems, it's a concept that we've been working on for quite a few years now. It all has to do with digital design, using BIM programs to completely design a building within the virtual realm, where one can identify your strength parameters and also cost, and then also how one will execute a building like this. From here, one can do joint testing in the real world if need be. And then from there, an entire building would be kind of documented and put on cutting layouts, ready for a CNC machine to cut these components. Components get sorted and get assembled by anyone who can actually just wield a rubber hammer. And this is really a philosophy which enables anyone to actually become part of the building process, and to allow them to also create meaning in what in the structures they build, and to kind of open the market up for anyone to build his or her own shelter. Okay, so let me show you a few projects that we've been working on that incorporates some of these design philosophies. The first one is in the furniture category. It's called Office in the Box. This is a very small design, piece of furniture that it was actually a competition project that we did 2 years ago for the DTIC. It was during the COVID years, so they asked for a home office solution, and we came up with this. This is a modular, actually just 3 timber boxes that are put into one another, and they can completely fold into a complete box and then open up to create a lot of storage space, a desk, and even a chair. Here you can see some of the assembly shots. So taking mind the components. We also use different materials, not just plywood, but nylon and aluminium to act as spacers or hinges. And this can really be shipped to anyone, and you can assemble it by yourself, almost like an IKEA set. It's completely customizable. You can have any color you want, any print you want, and yeah, you can kind of just tailor it towards your liking. So I would like to take that further to a secondary building element. So we've used what we have learned with the Office in the Box, and we've actually just enhanced that to create a complete partitioning drywall system. And this is really a multifunctional wall system. So this is a project that we are busy with for the University of Zululand. It's the new engineering building in Richards Bay. And we propose to, well, we're actually going to build these drywall systems within the building. It's all based on the principles of the of the Office in the Box system. So it's just actually, if you boil it down, it's just a bunch of boxes with different configurations that one can stack on top of one another, and you just bolt them, and then you have a wall, you have a desk, you have a bookshelf, you have a whiteboard, you have a pinboard, everything you will need in an office. And it also accommodates for all of your data and electrical reticulation services. So everything is contained within the system. And these are just some BIM drawings that show kind of how one would assemble them. So you would just give you can actually just give anyone these drawings and you tell them to put that box on top of that box, and then you'll have your walls. There's literally thousands of configuration types, different kind of bookshelves, different kind of desks you can get whiteboards, you can get pin boards, service boxes, anything like that. So, and this is just a modular thing that keeps on developing as we actually go. When you start to incorporate this in a different project, then you have another means of, or you have different challenges, and then it can actually just evolve from there. But yeah, it's actually just, yeah, it's a wall as a desk, a wall as a divider, in a completely functional manner. The third project I would like to show you is a primary building element that we've developed. This is a house we did in Mpumalanga in Middelburg. It is the house only has 3 stereotomic natural stone walls, and then you can see there's 2 monopitch roofs floating above the wall plate. And these roofs are made out of custom-made plywood rafters. There's 20 of them in total. They span a total of 10.2 meters, one rafter, and it's about 550 mils and at the steepest end of the beam. So the entire rafter is made out of birch plywood. You have a 21 millimeter core, which is the pink elements you can see, and then we use a 18 millimeter kind of cladding that you put on the sides to create overlaps, because we're doing face lamination to actually have your overlaps over the joints of the core, so you get a strong connection there. This is a typical 2D cutting layout that you would send to a CNC machine to do the cutting for you. All of the holes will be pre-drilled, all of them performing different functions. You have dowel holes, you have bolt holes for bolts, and also you have locator holes. We have holes for to use as rigging holes to help with the finger lamination, which I will show you now. But this is kind of how the construction would be. So the ceiling boxes that you can see here is also pre-manufactured. So you'd have your rafters installed, and then the ceiling boxes just drop in from the top. You fix it to the rafter, and then you can put your sheeting on. So yeah, this was the first. I'm going to show you some images of how this this rafters has developed. This was the first iteration where we just kind of figured out how we're going to do the joint testing. So this is the finger joints and how you're going to get a proper lamination on that. So as you can see, we have these threaded rods with ratchet straps, and you just pull them together and you hold it in place and get a very strong joint there. This was the first rafter that was cut, dry fitted, just to make sure that all of the tenons and mortises line up, all of the holes line up, and it's almost done. And that's the complete rafter in the workshop. You also notice that we use dowels for locators. So if you do face lamination, we use the dowels just to kind of line 2 elements up with one another to make sure that the tenons align with the mortises of the flanges that comes on later on. This is just a process where we do the finger joints. So you will do the first kind of sequence the whole thing, so you can do 2 beams at once. Also cutting on the assembly time. This is just some more photos where you can see the lamination process. This is the longer pieces that needed to be finger jointed. And there's the first beam done. The next day it was taken to site to be delivered and installed just to check if everything fits on site. And we had to drive all the way from Pretoria. When we arrived there, this beam was already up, and the contractor said it took him about 15 minutes from the truck to get it into position and bolt it on. He used 5 guys to get it in place and lifted it in place, and then just put the bolts through, and everything lined up perfectly. And from here we just started with the mass production. So doing two rafters in parallel of one another. So if you do lamination on the one that needs to dry out, then you can start with another one, and that just speeds up the manufacturing process. Here you can see the guys lifting these massive rafters into place. And that's during the construction process when the one roof was done. You also see the ceiling boxes with that's installed in here. This is the front end where you have the struts connecting to the rafter. And in this photo was when construction was almost done. You can see the clear story in place, and it really gives you this idea of a floating roof. We also have a different, this is a conservatory, so it's just a different roof covering, sort of like a greenhouse within the house. That creates, gives a lot of light into the room. This is some more photos from the bedroom wing, and then this was almost when the house was almost done. I don't have newer photos to show you. This is the most updated ones, and yeah, this is how it came out at the end. So the next project I would like to show you is also for primary building elements, is a project we did for the Royal Thai Embassy. They had a courtyard that was exposed to the sun, and they wanted to use the space to host meetings, and asked us to create a sort of like a covered roof. And we proposed this to them. So this is a plywood portal frame that have these large, we call it petals, suspended from the portals, and it really creates an interesting interior space. So the way it would work, we used the same method as that we learned in Potgieter. And so you would have your base plates, and you would have these elements, small components. Because it's a courtyard, you need to get all of the components within the courtyard. The embassy is still running, so you can't disrupt any of their operations. So the aim was really to have small building components that's not wider than 1.2 meters, and you assemble it on site, portal per portal. So you would set out all 4 base plates, and then you number the trees, the portals, portal A, B, C, and D, and then you would start with the one, and you do the first lamination, and then you go to the portal B, do the same lamination, and then you go on, and then with the time when you get to laminate tree A, then that glue is already dried, and then you can start with the second layer of lamination. So it's a really just a way to kind of speed up the assembly process as well. You can just kind of see how the whole portal evolved. And what was really interesting about this, and wasn't really planned, during the assembly process, we had 2 weeks of heavy rain here in Pretoria, and we couldn't really do anything on site. And then we decided to take all of the components back to the factory, and we just loaded them in the back of the bakkie, and we could assemble them all in the factory, and then just deliver it to site once the rain cleared. So this was just before the rains. We've covered it with tarps, and then we could actually just complete the installation from there. There's also the steel elements you can see on the sides is called cap struts, and that's used to keep the polycarbonate roof in place, but the portals doing most of the carrying. So this is also a photo, it's almost done, where you can actually see the interior space of the of these petals hanging down. Okay, so now that we've covered all of those, I would just like to show you some complete building systems, how we use timber for creating complete building systems. The first one is a project named Co-Spaza. This was an experimental project. So the idea of this is to actually create a building components and sort of like, and to have also as a portal system that you can just kind of add to it, and you can create a structure to your own needs. And this really allows anyone to kind of build their own house, even if it's just a tiny little 3x3 meter kind of shelter. So yeah, this is for this application, we use it as a coffee shop, but it can really be anything. It can be a tiny house. It can be pods arranged in different ways to create shelter. And here you can see the construction process. So first you will do the floors. You have the floor boxes, and then you build your first portal, your second portal, and then you put your what we call the wall boxes in, and then you'll have your roof boxes. And the whole idea is that with these system is it's kind of a monolith, it's a homogeneous kind of system. So on its own, that portal doesn't do anything really. It doesn't have any structural stability. But once you add the wall box and once you add the roof box, it becomes a really, really strong structure. So that's kind of the thinking you need to have when you think about designing these kind of structures. These are just some of the fasteners we use. Some of them are just normal off-the-shelf items. And the ones you can see on the right is what we call a pivot connection, something that we've developed to have to create footings out of, which I will also show you. Yeah, some of the components that's been cut within a factory, and they are laid out, they are assembled, and it's really, you just need a few screwdrivers and a rubber mallet. You just knock them all into place, all different elements that's being assembled, and here they are sorted and packaged, all numbered. So when it comes to site, you have them all like sorted, and you as you would build your building or your structure, you just take from the pile what you need at that stage, and you just continue from there. So this is so first off, obviously you do the foundations or the footings. So here you can see the base plates going on. That will be bolted to the concrete floor, and here the guys are busy with just assembling the footings. So this is a very small structure. It's 2.4 by 2.4 meters. Here you can see the first portal going up, wall box going up, and then your roof box going up, and then also you have a lot of structural stability just with that elements in place. From there, you put in your insulation and then your cladding. In this case, we used just normal corrugated just normal S profile, but you can have anything on it. You can have timber cladding, new tech cladding, whatever the case might be. This was really a kind of a pleasing project to be a part of. You really see how people that hasn't really done anything like this, how you can actually build a structure, and you can kind of see the reward there is into building something like this, and to have a complete structure at the end of the day. And it's a really good kind of team building exercise or teamwork exercise. There's not really that much frustration anyway, because everything just fits into one another, because it's all being figured out in the virtual realm. So it's just a very smooth going process, and that's one of the magic things about this kind of construction methods also, just from a human perspective. But here you can see the kind of the end product functioning as a coffee shop. So the last project I would like to show you is a much bigger scale project. This is the one that also used the kind of methodology of co-spaza, just at a much bigger scale. This is a complete house. It's a 3-bedroom house, 2 bathrooms. It's about, I think it's 8 meters wide by probably 50 meters long. It's a rectangular house. So the first, the ground floor is just a normal masonry construction with a concrete slab on top. Then you'll have these portals that's being pre-assembled in the factory, delivered as components on site, and you'll have these and here you have your wall boxes, same method, and then you just have your portal, wall box, and just like that. You can have it, and you have your cladding on top of that. The furniture is also modular design, so it's all CNC cut and pre-manufactured, and that just slots into the system. So here you can see, this is now screenshots from the model. The kind of your concrete slab with the base plates that's been set out, and then from there you would have your plywood portals that goes up, and then you have your wall boxes, and this is your main structure, and from there you'll just have your cladding that goes on top of that. This is just a view from the other side, showing how that happens. So these components are a little bit more complex, but very easy to actually install. So you just need to provide these kind of drawings. It's like a Lego set that you give to someone, and they just assemble all of these components. So this is, for instance, a wall box. It's kind of straightforward, and you just all you need to do is you need to sit with someone and you just tell them put component A to component B, and there you go. And it's a repetition kind of exercise. They're all the same. So once you've done one with them, so we would normally go out with the guys that do the assembly, and we will just build one of these portals with them, and then from there you can just kind of leave them and they continue on their own. So yeah, this is the kind of drawings that you kind of just provide for them. This is a beam being assembled, also with the insulation being built in. So you don't have to do that after the fact. What's nice about this system as well is you can actually include all of your electrical and plumbing services. So all of those routes are predetermined, and you can actually cut all of these holes in your members as well. So you don't have to have the electrician or the plumber. You don't leave it for him to decide where, or to kind of figure out where they should go. It's already incorporated within the system. So this is just some shots from where the components are being sorted. For this project, we used SA Pine and OSB, so it's all local materials. This is a portal member. Here you can see a kind of a connection, connects the portal to one another. This is also some shots of the portals. You also notice here on the left-hand side is recesses for the washers. All of that is being predetermined and accommodated for. And there's just some of the portals that's assembled. This is a beam. So I think this beam is about 500 mils in depth. It's a really, really strong beam, just made out of plywood. Also follows the same kind of principles as that house potgieter I showed you, also with the finger jointing. And this was images, and I'll just show you the final, well, not the final, the house isn't complete yet, but this is the first assembly of the portals. Here are the guys installing the boxes, and I think this is probably one of the best images, so you can kind of see the whole structure. So yeah, from here we just need to do the cladding and install all of the windows. So yeah, it's almost there, and then we can start with the furniture. But yeah, thank you very much. Thank you for your time, and yeah, if you have questions, feel free to ask.
Thanks, Christian. That was super interesting and nice to see some real projects happening. Bronwyn is asking, how does the use of timber impact the general insulation of the building? Does it meet the R rating easily based on the requirements in SANS? Is that something?
Yeah, I will answer that. So yeah, we have consulted with the SANS requirement, but in our case, we just use the OSB. If you just have that, you don't meet the requirements. So we've actually allowed for insulation as well. So within that box, it's 100 mil. You have 100 mil cavity. So you have we also included some rock wool insulation in there to meet the legal requirements.
Okay. Then there was a question from Lynn. Please discuss the option for covering the timber to protect it from rain. I assume that would be during construction.
Maybe I should jump in. I think it's kind of for both Christian and sort of CLT solutions. We tend to use a product. I mean, you'd probably relate to me saying something like the Tyvek home wrap, which is a moisture membrane it's a fairly inexpensive sort of almost like a fabric membrane that you cover the entire structure with. So Rotherblast make a version of this as well, which is, it's basically a water resistant membrane which stops direct water from running through, but it also allows the timber to breathe, which is an important concept also to understand, is that you never want your timber to be completely covered and it shouldn't be unbreathable. It needs to be able to still absorb and release moisture quite consistently. But yeah, there's quite a few solutions. It's a moisture membrane, and then you would basically just clad it like Christian showed them with that house arangis, you know, with a batten and then some sort of sheeting on top of it.
There is a question on VOCs. Are there VOCs from the timber adhesive? I guess it depends on which one you choose.
Let me jump in quick.
Yeah.
We've recently done some work as part of us doing a life cycle assessment for mass timber products, both glulam and CLT. We follow the ANSI standard, which is the American building standard, which the South African standard is built off of as well. Inside of that standard, they've limited the adhesive types to a certain number, and then also certain volume for specific adhesives that do have VOCs in them. At this stage, yeah, because you're using, in some cases, products like urea formaldehyde or melamine formaldehyde adhesives, there is the risk of VOCs, but it's nowhere near a toxic level. So from a mass timber perspective, it's not really an issue. I think, Christian, I don't know what your experience is with OSB, because OSB tends to have quite a high VOC output, but I know there's a lot of products out there that are obviously compliant, so it's not a serious problem.
Yes, if I can just elaborate on that, we don't have a problem with the OSB we used in terms of the VOC. We've also treated it quite extensively to so you don't get those. You're not affected by it. So yeah, there's and also the glue we use is also it has gone through rigorous. There's been a lot of R&D around it, so it is quite safe to use.
Great. Bronwyn, I'm going to get to you. Francois posted a question that I actually also had written down for myself. So the question is, who's the first point of call in designing timber buildings? Is it the architects or is it the specialist supplier, installer, or structural engineer. And it's challenging for architects to stay up to date with the latest construction methodologies.
I think, well, for us, I think it is quite a collaboration, I would say, between the architect, the engineer, and the manufacturer as well. We had a lot of meetings with Marcus as well and their company. So because timber construction is kind of a new thing in South Africa, or the way we approach timber construction in South Africa is changing. It's kind of a joint effort between all parties. And that's really how you get to the solutions quite fast, because you know where all of your design restraints for us now is. If you can just ask the manufacturer what you can do and what you can provide, and then we work from that. So it's really a joint effort, I would say.
To add to that, I think, again, I mean, I'm kind of laboring the point of the design guide, but I think it's valuable for the manufacturers to start or continue to develop products that really help educate and, you know, just create these free resources for people to understand where to start from. You know, we've managed to work out systems on our side, which we elaborate on in our documentation, where we can start designing like we would with a concrete system. So we're capable of working on an 8.4 grid so that you can fit your parking beneath your structure. So there's a lot of elements that you shouldn't have to worry about too much. My advice though is, once you have your basic formwork together, you know, and you understand some of the fundamentals where, you know, the hybrid system calls for really looking at certain sections of the building which you shouldn't really worry about doing in timber. So circulation and elevators and your core structures, leave it in concrete, design it as you normally would, and then expand with a smaller section of timber. So our rule with how we want to deal with clients is, for now, let's tackle 30% of the structure with mass timber and leave the rest as conventional build. And then once that project gets off of the ground, to be engaged with on an early stage in the project, where we can then get involved in terms of helping resolve technical details, connections, how things meet with one another, acoustics, insulation, all of the wrappings. We're very, very happy to assist with that. And we've got a team behind us from architects through engineers who can assist putting that together. So we are a resource that's available. Yeah, we welcome that kind of conversation.
Great. Bronwyn?
Sorry, I just want to ask again regarding the insulation. Marcus, especially for you, you said that when you were designing your glue laminated walls, you didn't go very thick. Is there a reason why you didn't go thicker, or did your insulation work out very similar to a double skin wall, which is 220, or even better so?
Yeah, so we're busy investigating the installation value that you know, when you look at the SANS regulation, the timber, because of its density, doesn't really meet the requirements for insulation at certain thicknesses. Although it's not really, we kind of argue that because we're designing in mass timber, if you're doing a wall, that the dynamics of that wall would arguably be different to a timber wall, which SANS usually relates to, which is just a frame wall and with OSB on the side. So at this stage, you know, for mechanical structural properties, we can do a wall as thin as 66 millimeters. Typically for like a 2-story building, 99 mils, we can actually carry up to 3 stories with a 99 mil wall. 99 mil thickness, you're pretty much there with the requirements for insulation. We do suggest, not because of heat transfer, but more because of sound insulation, that you have an additional layer of a very thin rock wool or equivalent insulation on the outside, which will just help the material perform way better. But we've seen that in many cases, Box has done quite a few projects with CLT walls that are just, I think there were 88 mils that perform very well under sort of South African climate conditions.
Thank you.
Graham, I see your hand is up.
Yes, thanks for your time and a great presentation. I wanted to know what is the kind of stance or position on the agricultural supplies of timber? Are the local timber growers coming on board, and are they getting the incentives, I suppose, from a financial point of view to join you guys on this, I suppose, revolution of timber construction?
Yeah, I mean, that's a really great question. We often get asked, are there enough trees to develop substantially with mass timber? We've run some different scenarios, both with Arup and there was another, I can't remember the other firm that was involved in that study. It's a very good study. I can post a link to it as well, which kind of speaks about mass timber in Africa and the abundant resource that's available, and what we're looking at, the scale of development that we're looking at, especially considering a hybrid system, which seems most feasible economically as well, that there's more than enough to maintain a very, I guess, sustainable and circular system. So we're never going to run out of trees by building with mass timber at the rate that we're constructing now. The next thing is that the sawmilling industry as a whole is very excited about mass timber. Part of our second sort of build-up period, where we're kind of expanding to multiple facilities and servicing different locations in the country and in East Africa, we're offering a substantial value addition on timber, which the sawmills aren't really used to. Typically for years, the sawmilling industry has been creating, the standard section sizes, the 114 by 38s, and the 228 by 50s, and they've been making trusses out of them. And that market is just not really doing what it needs to do for the sawmills to keep their doors open. So I think the sawmilling industry is becoming more open to supplying very specific material to us at this early stage. And our ability to actually use more material that would maybe not be so select for truss making or the sort of builder's warehouse market that they usually serve. They're quite keen to engage with us. So yeah, we don't think there'll be supply issues for this at all. It's more about seasonality. So having a really high demand peak in wet seasons when they can't cut down trees and dry them fast enough, that might be an issue, but we're working on that to ensure that that's not a problem. Yeah.
Nice question. Any other questions from the floor?
Hi, good afternoon, everybody. Just from a fire perspective, how is the timber treated? Is it done in its plank form, or is it done after the timber has been cut?
We don't treat our timber for fire. So the benefit for fire on mass timber is that, much like the concept of adhering the timber together to get a uniform, predictable engineering curve, we've been able to do studies where the fire curve is also very understandable. So timber burns in a solid form at a rate of about 1 millimeter per minute, and it creates a char layer which really slows down the way that the timber burns. Also, it doesn't buckle under high heat. So like steel, after a certain heat temperature, it actually starts melting and twisting and loses all of its structure. And with a certain degree, concrete also just starts degrading. But timber just burns at a consistent rate. So when you start designing with timber, again, in the design guide, there's a chart for all the different scenarios, the different thicknesses you would require for different fire ratings. But yeah, we can reach up to a 2-hour fire rating with certain panel thicknesses. I think up to 150 mils, we can get up to 2 hours as a composite slab with it's got a concrete topper on it. But 60 minutes, 30 minutes, that's no problem for us at this stage. Yeah.
Great. Okay, last question, AJ.
Thanks, Marlies. Yeah, first of all, it's great talk. Really exciting. I'm actually a little bit jealous of you guys. It seems like you're having all the fun stuff. Just if I may sneak in 2 questions quickly. The first one is just engineering, especially Christian, some of your projects, it looks like it's highly engineered and very detailed. So I was just wondering which sort of consultants you work with, because I'm not sure whether all engineers could actually, design things like that. And then the second one, which was probably partially answered earlier, but which waterproofing products do you guys use, especially on like a freeform roof, where, you have to almost have a rubberized bond? Yeah, from my technical questions, but quite curious. Thanks.
Yeah, we always have the challenge of finding an engineer that's willing to assist us with with our structures. So, but we have been fortunate. There is a few people here in Pretoria that's quite keen. We have engaged a lot with the University of Pretoria as well. They actually have a timber chair there at the university that we have used quite a lot to do some of the testing for us, to do some of the load tests, and also to help with some of the details. That house, for instance, we've also we got an engineer, 70 by 60. His name is Chris Greensmith, and he's also quite excited about timber construction. I think the main challenge, if you would want to get the correct person, is you need to find someone that has a little bit of background in mass timber engineering and that's also excited about it. And then you can actually learn a few stuff. They can learn a few stuff from us, and that's how we have developed, like for instance, that plywood that plywood rafter. Was also his first time doing that, but it was quite a good experience. And then if I can just, your second answer, the waterproofing products we use, at the moment we're only using one product from Woodok. So we have also worked with Woodok for quite a few years now. We know all the products. It's also a local producer. So they have a product called Woodok Waterborne Marine. So it's not like a varnish, like an oil kind of preservative. It is a water-based preservative. So it actually, the timber absorbs the preservative, and it gives you a lot of, there's a lot of advantages to that. So and that has worked well for all of the structures that we've done so far. Also provides a bit of UV protection as well, so the timber doesn't change the color, but you will get that with timber. But that's just one of the characteristics about it. Yeah.
Great. Thanks for that. I'm going to wrap up. I just want to mention lastly that thank you for all your questions in the webinar. It's really appreciated. And thanks to Christian and Marcus for sharing their experience. Just on next events, next month, we're going to do one on net zero waste or zero waste, and how you design for that and how you operate a building on net zero waste. And then in July, we're looking at urban green spaces. Thank you again to our speakers. Thanks, Christian. Thanks, Marcus, for your time and your experience and the stories you shared. It was really, really insightful. And I think from all the clapping hands coming up, is definitely appreciated by everyone. I just also wanted to thank our sponsor for contributing to our webinar. We really, really, really appreciate it. And with that, I'm going to say thank you. Thank you for attending. Thank you for your participation. And I hope to see you next month. Have a really great evening.